Hello and welcome to our another session of measurement in industries. Today we will be talking about something related to water, something related to moisture. So yes, today we are going to talk about moisture measurement, or you say humidity measurement, or the water content in the atmosphere or in some material. I am a course instructor Mausam Padia, and today we will be talking about hygrometer. So we will start what is hygrometer with some basic definitions related to basic terms related to hygrometer and humidity, and a few classification. This entire session will be delivered in two videos. Some classification will be taken in this session, and few along with the hygrometer will be in the next session. So what is hygrometer basically? We know, like, due to humidity, material has got changes in say physical, chemical or electrical properties. So these properties are changed due to humidity, as we all know. Like say if it is a piece of paper, so if it is humid, then it becomes smooth instead of crispy. Then some chemical changes are there. Say electrical properties are changed, conductivity increases. So this property, whatever changes are detected, that is used to design our transducers. Basically, the entire course is all about measuring. So here we are talking about measuring humidity. So we will be using the change in such properties due to humidity to design our different transducers, and we will be calibrating this transducer's output to read directly in terms of the relative humidity. So we say the device used to measure the humidity of the atmosphere or some material, that will be known as hygrometer. Let's see some basic terms here. The first one is moisture. It means water content of any material or a substance. And basically here when we say moisture means we talk about solids and liquid both. Another is word humidity. Usually people use interchangeably humidity and moisture, but they both are different idea. And here humidity is a term which is used to talk about water content in the gases, or you can say in the surrounding air. Next comes, that's a very important term, that is absolute humidity. Absolute humidity is specifically ratio of mass of water vapor to the volume of the air. So if you talk about say a particular volume of air, then what is the amount of water vapor say in terms of mass? So AH absolute humidity, that is M by V, and here absolute humidity does not consider the effect of temperature, but for a particular point of temperature it may have different value. So when we say we talk about say absolute humidity, we consider some temperature remains constant. Next comes is relative humidity. Here relative humidity is one more important term, where it is actually again ratio. So it is actual water vapor pressure present in the air at a certain temperature to the maximum water vapor pressure present in the air at the same temperature. So keep in mind, I repeat once again, you take a constant temperature or specific temperature, at that we will measure the pressure of actual water vapor, and we will measure the maximum water vapor, and we'll take the ratio in the air, specifically in the air. And here from definition you see, this relative humidity term is taking both into consideration our temperature and pressure. Now, hygrometer, what does it measure? Does it measure absolute humidity or relative humidity? So please keep in mind, unless and until it is specified, we will be by default measuring relative humidity. So our measurement, when we say we measure term humidity, so you understand it is relative humidity. Humidity sensors. Actually, say you must have heard of DHT level. So DHT level is not only measuring humidity, it also measures the temperature also. So these sensors are commonly used for average measurement. They also measure the air temperature. So because the humidity depends on the temperature also. Specific humidity. It is again a ratio, but it is a ratio of two masses. One is mass of water vapor and another is the total mass of the air under consideration. So keep in mind, ratio of mass of water vapor, the mass of air. Next is mixing ratio, or you say humidity ratio. It is the ratio of mass of water vapor to the mass of air, but here specifically we say dry air. So in specific humidity we need not consider whether it is dry or wet. So this humidity ratio may be equal to specific humidity, but specific humidity is always not equal to mixing ratio. The one very important term again, that is dew point temperature. So it is a temperature where water vapor is saturated in the air. Like there is a limit. Beyond that, air cannot hold the water vapor. So it is a temperature. It is a temperature at which the water vapor content is saturated in the air. And we say a dew point temperature, the relative humidity is 100%. Now let us recall what is relative humidity. So that is 100% in dew point temperature. So this will be one of the reference that we will be using in optical type of hygrometer. Now for the air to hold maximum amount of water vapor, it has to reach where dew point temperature. So ultimately that is explained by the definition of dew point temperature. Now we'll see classifications of hygrometer. Some 6-7 varieties we have. We'll be discussing one by one. The first one is capacitive humidity sensors. Obviously, the sensor will measure the humidity, water content, and it will be used by using the principle of capacitance. So here we will be using air-filled capacitor, and definitely we know the electrical permittivity of air. That is, we say epsilon 0 into epsilon r is equal to some amount. So for air, relative permittivity, relative electrical permittivity is 1, so it is absolutely epsilon 0. But when moisture is introduced in the atmospheric air, it will change its electrical permittivity. And the equation for electrical permittivity is given by here, the 1 plus in bracket 211 by capital T into P plus 48 by TPS into H into 10 raised to minus 6. So what are these terms? The K is electrical permittivity, P is absolute temperature, then P is pressure of moist air, then PS is pressure of saturated water vapor. Obviously our temperature in consideration, absolute temperature is 0 degree Kelvin, and H is relative humidity in percentage. So definitely what we'll do is we will fill up the space between the capacitor plates with the appropriate dielectric material. We say it is also known as isolator, but isolation is in terms of say electricity, but charges will accumulate on each plate. So we started with the air-filled capacitor, but we may have some other dielectric material also, and whose dielectric constant will vary with the change in the humidity. So here some diagrammatic presentation I am showing, and for the modern capacitive humidity sensor we will be using polymer material which are sensitive to hygroscopic properties. Here you can see 4 layers. One is protective polymer layer, then polymer layer for dielectric, and as an electrode above the dielectric electrode layers are given, and for the base substrate the silicon will be used. So the common method, as I said, to design one capacitive RH sensor, to use hygroscopic polymer film as dielectric medium. You can see that I have shown with the red arrow, that is hygroscopic polymer film material is used here, which is deposited between the two layers of the polymer electrodes. This was one method. Another is frequency based in the capacitive humidity sensors. So what we'll do is we'll have two capacitor plates as usual, and it will be given some oscillatory frequency. So when there is no material between two plates of the capacitor, the frequency, resonating frequency or vibrating frequency will be different. Now test samples. Say for example, it is oftenly used in pharmaceutical products where medical tablets are being placed between the two plates of the capacitor, and here as test sample, say medical tablet, the LC oscillatory circuit will have different frequency. So this frequency will be proportionate to the humidity present in the material, which is actually already calibrated in terms of RF. So change in frequency will indicate the relative humidity here. Now next, for the another type, that is resistive humidity sensor. Here resistive humidity sensor, obviously it says that we will be using the fundamental of resistance to detect the humidity. As we know, resistance changes with the water content. Obviously the relationship will be inverse, like as water content increases, electrical conductivity is also increased. So it means resistance, or you can say resistivity, is decreased. So relationship between resistance and humidity is inverse. Usually it is inverse exponential. Here you see the sample graph where resistance is decreasing with increase in the humidity. And here what we are going to use, sensors have relatively very low resistivity, because with having low resistivity it will respond for even very small change in the RH. Resistive humidity sensor. Now resistive humidity sensor is having the similar kind of construction, but here instead of dielectric medium we will be using comb electrode with the humidity sensitive film. As I said, we will be using low resistive material which is deposited on top of two electrodes, and electrodes are placed in comb pattern to increase the contact area. Let us see how will it look like. Here the top section is shown. Comb electrode, you can see protective film is shown, then ceramic substrate which is actually forming the base, and humidity sensitive film is there, then electrode and external connections which are laid out are shown here. Here we will be using say some salts are commonly used of specially treated substrate, then solid polyelectrolytes and some conductive polymers will be used as resistive humidity materials in the sensor. And here electrodes are to be very sensitive, minimum power loss and signal loss should be there. So they will be made up by normal metals like some gold, silver or platinum. Here you can see once again the cross section of the humidity sensor where platinum and silver electrodes are shown. The resistivity between the electrodes will change when the top layer absorbs the water, and these changes can be measured with help of a sensitive bridge circuit, because whenever resistance changes, that bridge will be unbalanced and some voltage, millivolt output will be given in proportion to the change in the resistance. Now resistance is changed in proportion to humidity. So ultimately the unbalanced voltage output will be reflection of the humidity, and this way we will be calibrating this in terms of relative humidity and will be measured. As I said, the electrode will be made up of gold, silver or platinum. The next is thermal conductivity humidity sensor. So here obviously when we talk about thermal, we need to talk about the temperature, and here we will be talking about absolute humidity, and this is also known as absolute humidity sensor. And here we will be using the measurement of thermal conductivity of two things. The one is your reference, that is the dry air, as well as air with the water vapor. Here you see the diagram where some supply is given and ambient air is enclosed, then dry nitrogen filled thermistor is there, and it is actually forming a bridge circuit. It is actually forming a bridge circuit. You can see there are 1, 2, 3, 4 resistors are shown. It becomes a bridge, and one variable resistance to set the output between 0 to 13 millivolt. Obviously this millivolt will be amplified for the measurable display. And here what we will measure is, we will measure individual thermal conductivity to be related to the absolute humidity, and then we will be taking the difference. Once again you see here thermistor with negative temperature coefficient. Obviously thermistor will be NTC or PTC, but most probably we use popularly NTC type of thermistor. And as I said, it is part of the circuit. The one is sealed in a chamber filled with dry nitrogen, and another is exposed to the open environment. Here you see with the yellow color that dry nitrogen filled up, that is the sealed chamber, and the with the holes we have shown holes from where the our reference or our sample under measurement will be entered there. Then there will be change in the some thermal conductivity, and the difference will be measured directly proportional to absolute humidity. The next is optical hydrometer. So when we say optical, means we are talking about some light rays. Okay. So optical hygrometer actually is based on the absorption of light by the water content in the air. So as water content increases in the air, the absorption will increase, and the reflected light will have difference at every content of the water vapor. So here one light emitter diode or light emitting LED source is given, and a light detector obviously, and there is a volume of air between them. You can see here mirror. That mirror is managed at certain temperature. TRD, that is TRD is temperature measuring device, and that Peltier coil is kept here to measure. So the light attenuation of light will be detected by the light detector, and actually as I said, every part of water content, like if water content increases, the absorbed light will be changed in the proportion which is actually detected by the light detector, and that will be based on the Beer-Lambert law. We will have a specific station on that also. So here you see TRT, which is measuring temperature. Here in the second diagram, you see there is a mirror whose surface is precisely regulated by a thermoelectric heat pump. Okay. I have made the red circle of the thermoelectric heat pump. Then mirror is controlled by a controller at threshold value of dew point. That will show what is dew point. That is the saturation of water content in the air. Then sampled air is pumped. Sampled air is entered over the mirror surface. Here I have shown with the dark circle once again. And now what happens? The mirror temperature crosses the dew point, and it releases moisture in form of water droplets on the surface of the mirror. Now, refractive properties of the mirror changes because water content is there, and droplets will scatter the light rays, and then detected light rays will have difference that will be detected by the photon detector. So this is the basic principle of optical hygrometer. There are 2-3 varieties of optical hygrometer. The one is Lyman alpha hygrometer, where Lyman alpha light emitted by the hydrogen. Then Krypton hygrometer, where approximately 123 nanometer light spectrum will be emitted by the krypton and will be utilized for detection of light. Then differential absorption hygrometer, where two lasers will be operating at different wavelength, and one will be absorbed by the humidity and other will not. Now we have finished some 3-4 types, and we will be having in next session hygrometer, then aluminum oxide hygrometers, and hair hygrometer. This hair hygrometer is a very interesting thing, which was actually invented in somewhere year 1700. So these 3 things we'll be looking into in our next video session. Till then, thank you so much.